So here we are going to solve another CSIR NET June 2023 problem. The problem is two distinguishable non-interacting particles, each of mass m, are in a one-dimensional infinite square well in the interval 0 to a. So it's a asymmetric square well. If x1 and x2 are position operators of the two particles, the expectation value x1 x2 in the state in which one particle is in the ground state and the other one is the first excited state. So you have to find the x1 x2 expectation of x1 x2. So the combined wave function can be written as psi1 and psi2, where psi1 is the wave function for first particle and psi2 is the wave function for second particle, whereas psi1 is root 2 by a sine, since n is 1 here because it is in a ground state, so pi x1 by a because n1 is 1, and psi2 is root 2 by a sine 2 pi x1 by a, as n2 is equal to 2 here because it is in the first excited state. So now we have to find, they are asking to find the expectation value of x1 x2. So the expectation value of x1 x2 we can write as psi c x1 x2 psi c, which if we convert into integral can be written as 0 to a psi c star x1 x2 psi c dx1 dx2, which can be further simplified. If we put psi c star, then it is psi 2 star psi 1 star x1 x2 psi 1 psi 2 dx1 dx2. So this can be written as psi 2 star x2 psi 2 dx2 0 to a into psi 1 star x1 psi 1 dx1. So this basically reduces to expectation value of x1 and this is expectation value of x2, because this is nothing but expectation value of x1, this is nothing but expectation value of x2. Now we know that for a asymmetric infinite square well, expectation value of x is a by 2. This can be proved also. So suppose let's first take this first wave function. So if we want to evaluate this integral like psi 1 star x psi 1 dx1, then this becomes 2 by a sine square pi x1 by a into x1 dx1. So this 2 sine square theta we can write it as 1 minus cos 2 pi x1 by a x1 dx1. So this is becomes in two parts. First part is x1 dx1 0 to a, and the second part is x1 cos 2 pi x1 by a into dx1 0 to a. Now if you evaluate this integral, you will see that this integral vanishes. Only remaining part is this one, so this is nothing but 1 by a into a square by 2, so that is a by 2. So if it is a by 2, similarly if you evaluate this integral, this also will give you same answer. So our expectation value of x1 and x2 becomes a by 2 into a by 2, which is a square by 4. So this will be the answer for our problem. So I hope this is clear. If you have any doubt, let me know in the comment section. We'll meet in the next video.